Hi there, welcome back to the channel. Welcome to the second video in the restoration series of the SABA Stereo I. As promised, I did the power supply section, checking the entire power supply section, filter caps, la-di-da-di-da, checking everything, making sure that everything is working correctly on that very, very crucial part of the radio. If that's not working, the rest, forget about it. So I went through each stage as I normally do, and just as well that I did go into quite a bit of detail because, as one of you pointed out, there's a type of resistor on this radio that is going to give me quite a few headaches. I think it's 3 out of 3 so far, but I'll let you see for yourself. The point is, I wanted to go through this very carefully because this supply is slightly different to the usual. This one supplies both tubes and the transistor section on the decoder and on the FM front end. There are a couple of transistors there as well. So the supply is a little bit more complex. It's got a negative bias, fixed bias on this radio rather than the cathode bias that you normally get on most tube radios. So again, there are a few elements here that make this just a little bit more interesting for me than another tube radio. I hope I haven't gone into too much detail to put you to sleep, but if you're interested, stick around and enjoy the video. I started as I usually do with the power supply, and more specifically with the front end of the power supply. Now, that switch that I put in there is working very, very well. And there were questions raised as to whether this is correct, because what it means is that with this system, you can actually have the switch on, powered on, when none of these are in place. That is true. Normally, when you activate one of the functions, it pulls on the power, and that would click that down. But I'm not sure if that's the case here. It looks like you can actually have all of them up. Now, a friend of mine, Derek, sent me a little video where he shows on another SABA that this is possible. In other words, you can have all of them up and the power on. And what it does effectively is it heats the tubes up. So the tubes get heated up when you power it on. If you've got nothing on there, then you can activate one of the functions. Well, it makes sense. I'm not sure if that's the correct way to do it, but I did notice this one is actually a little bit higher, and there's a little bit of a metal tooth in there that's been filed down. And I think that metal tooth is what would have done this. In other words, when you push that down, it would have released whatever is in here. I'm not sure. The point is, this thing works. Another thing is, somebody sent me some photos of a Constance, a SABA Constance, and it's got this very, very similar switch to this. Regardless, this is the way I'm going to leave it. If I find a different solution as I go forward, I might implement it, but for now, that's how it's going to stay. And so what I decided to do is to focus on the filter caps. I actually removed them. They're very easy to remove. Now, these filter caps have got different ground references, so you've got to be very, very careful. The bottom one is actually referenced 100 ohms above the chassis ground. So the ground of these two capacitors is actually going to that end of that 100 ohm resistor, the negative of the supply. And then there's a 100 ohm resistor to ground. That resistor is perfectly fine. I measured it. And then it joins up with these two caps over here. And these are actually referenced to chassis ground. Even though they've got an insulator there, that ground connection is directly to the chassis ground. So you've got two different grounds. You've got to be careful on here when you put this together. And what I decided to do is the usual thing. I removed these guys. I actually removed all the stuffing. You have to undo that ledge on there. This one is particularly difficult to do. It wasn't as easy as some of them. So the result is not as neat as I would have liked. But I put in two 47 microfarad 450 volt caps in there, built this up again, put it back, soldered everything in place, checked all the components on here. So there are 3 resistors on here, a 180 ohm, a 1K8, and a 68 ohm. Those are perfectly fine. I've checked those as well. I replaced this death cap over here with a safety cap, 22 nanofarads. This is the one across the secondary of the transformer. And of course, because I did the cleaning of this with my air compressor and alcohol and everything else, and a mask. Yep, I put a mask on. So this whole section here has been cleaned up. I've actually gone and cleaned some of the switches as well. But so far, what I've got is a power supply that has the filter caps replaced with new caps inside. The original or the initial resistors that serve as dropping resistors between the B plus stages have been checked. They're all good. And of course, this would not be an electronics old and new video without the painting of the schematic. I really love the system, believe me. Here we have it. I've drawn this in as direct because there's no switching of that second phase over here. Not as good as I would have liked, but that's the way it is. It goes through here. There's a fuse. I've got the switch on the side. Probably should have put it on that side, but it was just the one that was most easily accessible. It's easy enough to swap around, but I'm leaving it like this. This section we checked before because both the dial lamps are coming on. That fuse is fine. I can see it on the back of the supply plate, and it's working because these are working as well, and the tubes were getting heater voltage. And the other thing is I can now carry on here. So I've replaced this capacitor. That's why I've painted it in red. I've got these two guys. Actually, this is something I left out. These guys have been replaced. All of them. Oh, much better. I feel much better already. Forgot that. But there we have it. 100 ohm resistor checked. 180 ohm resistor checked. 1K8 checked. This 68 ohm checked. That's a little green one at the bottom. So I've got this whole section checked and working. I'm going to leave this to the end and see if I need to replace it or not. If it's got too big a voltage drop, I'll replace it. Otherwise, I might just leave it. It looks pretty sturdy and it looks pretty unique as well. Now I've got to take this one step further. And the way I do that is I go to the B pluses. I'm going to start with this one. This is that negative supply that I mentioned. It's for biasing some tubes. I'm going to start with this one, which is the main B plus, but it is effectively B2 plus. They call it +2, +3, +4, +5. So I'm going to take this B2 plus, and the way I do this is I check where it goes. I can sort of guess it goes to the center of the primary of the output transformer. And then through each of those primaries, it goes to the respective anode, through there to there to there, of the power tube. And there's one thing I need to mention about this power tube. It's actually got a triode incorporated. I forgot about that. There's a triode and two pentodes. So this thing's got amplification, and then there's the pentodes. So I need to make sure that 2 is coming to there and to there. And there's one more place. And that is obviously on the other channel. 2 comes in here, goes to there, and goes to there. So the way I check this is I look for 2, which is this point here on that capacitor, the one that is referenced to well, not referenced to ground. I put my multimeter on there, and then I look at the anodes of the tubes, and I know that the anodes of the tubes are pin 3 and pin 8, and I should get a fairly low resistance because all I'm measuring is the resistance, the DC resistance of each of those windings. So let's do that. So I'll go to the first tube, pin 3, 1, 2, 3. I get 600 ohms and 8, 728 ohms. That's fine because when you have 2 windings on a transformer with the same number of turns, one of them will be outside the other one. So there'll be less wire to get the same number of turns, if you know what I mean, because the diameter keeps getting bigger. So the resistance, the DC resistance will change. Let's go to the other tube. About the same as the first one, and pin 8, about the same as that second one as well. So our tube supply is coming to both of those points, which is what we want. And what that means is I can start painting here as well. So my 2, which I believe only goes to those points, can be painted in there and here as well. So that's done. There we have it. Our 2 has been taken care of. So now we will go to supply 3 and find out where that goes. Somebody actually asked me whether you need to remove all the resistors, lift one leg to test them and all that sort of thing. Not really. Most of the time you don't. I'll give you an example. I'm going to actually carry on. Instead of going to B+3, I'm going to go to B+5 because that's the one that supplies the ECC83. And I'm going to put it here on the position where B+5 starts. It's at the end of the 1.8K resistor. And now I'm going to follow it and see where it goes. So we've got our +5 over here, which I can actually paint if I want, because I'm going to take it off here. And this particular supply is from there to there, drops, and there's another capacitor here. It's referenced to ground. And I'm going to see where 5 goes. Now, I believe it only goes to one place, and I believe it's this place over here. I can see it goes to various places. Here it is. 5 comes in. There's the first point. It goes to pin 9 of the ECLL 800s there as well. So pin 9 I should get no resistance. Then pin 1 I should get 150K. There's no other resistor over here. That capacitor blocks DC, so from 5 to pin 1 I should get 150K. I believe the same will apply. Where's pin 1? There's pin 1. There's 150K, and it goes to 5. So I've got those 2 resistors I need to look for. Where else does it go? It also goes to here through a 47K resistor, and it meets a capacitor, which is another sort of B plus filter cap, small one, 2 microfarads, which I'll probably have to swap out. I need to find it. And it goes to the anodes of the ECC83, you see, through 220K. So from pin 5 to pin 1 of the ECC83, I should measure 220K plus 47K. And the same applies here, 47K plus 220K. So I know what resistors I need to look for, and I'm going to check what it is that I get. So let's start. What am I looking for? Pin 9 of the ECLL 800s. Both pin 9s, I should get 0 resistance or close to 0. Yep, that's good. That's good. And pin 1, I should get 150K. So pin 1, 157, that's within spec. There's pin 1. 157, again within spec. So I can go here and I know that those are fine. So I take 5 from here to there. And I know that those are fine, and I know that those resistors that I've measured are perfectly fine. Now I take the next step, which is from here to pin 1 and pin 6 of the ECC83, and I need to measure 220 plus 47, about 267. Let's see what we get. Pin 1. It's a bit high. $340. Why am I getting 340? See, I've got 220 plus 47. So this might be the problem. This resistor might be too high. I can check that by measuring between 1 and, I don't think there's any other, no, there's no other resistor. So this is DC resistance. I can measure from pin 1 to pin 6 and see if I get close to 440. And then I'll know that that 47 is too high. So 1 to 6, what do I get? 578, those are high. I should get 440. I need to find those resistors. They seem to be too high. Okay. Those 220s are resistor 424 and 524. I think this is one of them. No. I can't really see the markings too well. Oh, here they are. 524, what do I get? 290, yep, that's too high. And this one here, 280, again, that's too high. So those two 220s are wrong or bad. Let me see if the 47 is okay. So I'll go back to the connection, the joining point of those two resistors, and measure to here. 48. So that one's fine. Okay. What have I determined? I know that that resistor is fine. And that one isn't. I know that that connection is made. So now I need to replace those two resistors with 220 ohms. 220K. Let me do that and get back to you. Let me show you some magic. I want to know where these resistors are. That's the joint over there. There's two over there. I can see them. So I know exactly where that is. And what wizardry is this, you may ask? Well, it's actually a thermometer. I shine it on it's got a laser pointer. I shine it on the joint up there, and it tells me exactly where those resistors are. So you don't desolder the wrong ones. So let's get to it. I prefer a solder wick for these because I'm not sure what condition this board is at. You've got to be very careful with this. You've got to assume that these boards are very fragile after all these years and the fact that they were sort of early boards. So don't risk much. Take your time. I'll take one of these clips, clip it on one leg of the resistor. Usually that seems to work. Actually, this one doesn't. So I'll use this guy. I've got to be careful that I don't melt any of the wires around here. That's out. There's our first one. Let me try and just take this out. There we go. There's the second one. I'll clean the pads with a solder wick. And we're good to go. Now I've got these 220K resistors, 2 watts, and we'll just fit them in. Oh, this is so difficult to do with the camera in place. One. Here we go. Be careful of these things. If they get left around, lying around, you can get some pretty bad short circuits when you switch this thing on. This is especially true with the point to point, but we're done. And of course, you've got to recheck them. So we want about 267. That's pin 1, perfect. And pin 6, perfect. Right, that's good. And so now we can go back here and we know we've replaced that one. So we do this. Good, and we've checked 5. See, this is all it takes. It's very slow. You've got to enjoy this sort of thing. I do. And it's much easier to do it this way than going one by one. You just keep eliminating suspects. As you saw, I wanted to find out where the problem was. I guessed it was probably these two because the value is about the same. So I measured from here to here, got 47, eliminated that as the problem. And then we measured between here and here. And these points are all easily accessible at the top through the tube sockets. So you can very easily measure. And we figured out we've got 2 bad boys over here, which means we're going to have quite a few more. Because all these resistors would have aged similarly. So the ones that are, of this type, we have to be suspicious of. All right, that's one more line tested. Next, I'll be doing this 3. Now, here's the first sign that perhaps that switching system of mine was not correct. This 601 dash is actually the power switch. If we look here, we've got the on-off switch. There's 601, 601 dash, and 601 dash dash. I think they've probably shorted those out because this switch is no longer operating as a switch. All I'm using this for is to pull the thing down. I'm not sure exactly where this switch was. It's not on here, so it would be on here, but it seems to be linked up. I don't know what the story is here. Anyway, the point is, it seems to have been shorted out. So I'm taking it from the top of this capacitor, and I've marked 3 places where it goes to. We'll go one at a time. This one here goes through here, through a 380k resistor, a 68k resistor, and it goes to pin 1 of the EAF801. So I should measure either, depending on this switch, either 330, or rather either 680 or 398. And this U9 is the switch over here. U9, so it'll be the outer switch over here. We don't need to worry about that. We just know that U is in the, what is that, FM or phono? It'll be FM. Okay, so we'll try both. Let me check what resistance I get at pin 1 of the EAF801. It's that one there, pin 1. I get 399. So 399, that's correct. 330 plus 68. Perfect. So those 2 resistors are fine. Now, just to make sure the switch is fine, I'm going to deactivate it. 69 should be 68, so that one is perfect. So we can paint that. That one is done. The next one, this one. Let's see, it goes here through a 3.3K resistor. It meets capacitors, so there's no DC effect. It goes in here, it goes through that primary coil. That should have a small DC resistance, probably very small compared to 3.3K. So we're still at about 3.3K. It goes through that primary as well, another small DC resistance, and it goes to pin 6. So what I expect to get at pin 6 is 3.3 something K. 3.3 something K, pin 6. 1, 2, 3, 4, 5, 6. 3.26. Well, that's good enough. So the resistor is slightly low, but that's perfect. So we can paint that up as well. So we've got those done. What else do we need to do? 3 comes in here as well to the magic eye, and it comes into pin 6 and with 0 resistance, and then a 1 meg resistor to pin 7. Where are we? 1, 2, 3, 4, 5, 6. So it's to there. 0 and then 1 meg to pin 7. It's that resistor. Oh dear, 1.5. So that guy's got to be replaced. That's another one of those brown ones. Whoever commented on that was correct. These brown ones are proving to be a nightmare. Let me do that, and then we can paint it. Let's just check that again. So to here, we've got a direct line. And to there, we should have about 1 meg. Yeah, 1 meg. Done. That one's done. So we can paint it. And that is 3 done. We're making progress. Well, I believe I've done all the checking that I need to do for the supply lines. You'll see that we've got quite a bit painted in, and I did make a few changes or replacements. That resistor there you saw me do. There was a capacitor here, that one there. That capacitor was replaced. And there was one more capacitor. This one's actually a low voltage capacitor. It's actually wired in reverse. The positive goes to ground. That's from the negative bias line. So that was replaced as well. And this is where this negative bias line comes in. Normally, if we look at the output stage, which is the stage that I'll be doing next, the audio stage, all this will be checked. But if you look at this, the 2 pentodes have got their cathodes connected directly to ground, which means you can't use, or this does not use, cathode bias. It uses a fixed bias on the grids. And that fixed bias has to be negative relative to ground, which is why we have, quite conveniently, that minus 10 volts over here. You've got a 47K over here, then it goes and it gets stabilized over there with the 50 microfarad capacitor at minus 10 volts, or slightly less than that, minus 8 perhaps. Then it goes down here, it goes to both sides, but if you follow it down here, it comes down here, it goes through a 1 meg resistor, and then through another 1K grid stopper, and it goes to one of the grids of the output pentode. If you follow the other one, there's the other 1 meg resistor, the 1K grid stopper, and it goes to the other grid. So both of these pentodes are being biased at minus, or from the minus 10 volt line relative to ground. In other words, the grid to cathode voltage becomes negative, which is what you need for biasing a pentode. So that's why they use that. And of course, that applies to both sides, top as well. This line does go up there. Now, I'm going to leave the audio stage for my next installment. There may still be 1 or 2 lines here that I haven't checked. And I know that this voltage 4 goes into the FM block. It then is used to power these transistors over here. You can see that. That line B goes to there. This there indicates that it goes left and right. You have to sort of learn the language of the schematics when you get to them. This arrow left and arrow right means this line goes to both sides. So if we follow to the left, there, we find the next point that shows B, which is pointing to the right. So that's telling us that this B is pointing to that B. And I followed that up, and you can actually follow that to the pins of, or to the tube socket of the ECC85. And that goes to pin 1, and that goes to pin 6. So I was able to check those connections, check those resistors, the values, they're perfectly fine. But it also goes to the right. And if you follow B to the right, you come here and you've got B. And it means that this is B, but it also carries on. So if we follow up here, we've got this going up through a 150K resistor to bias that, or to power that transistor. Now that's inside the whole FM block, which I'm not going to remove right now, and hopefully never. I pray that I don't have to open it. But it also carries on, goes on through here, and it goes up. So if you go up here, up here, where's B? You got to look for where B appears again, and there it is. So it is used to power the connector board, or the section that receives the FM decoder. So that's obviously also a supply line. So you see there are some power lines that are rather more difficult to detect than others. So what I've finished now, when I say I've finished the power supply, that does not mean that there may be something still wrong with it. I hope not, but this is where I'm going to leave the power supply for now, because my next stage is to focus on this section, that section, and to be able to input an audio signal at the, where is it? At that socket over there, the phono socket, external phono socket, and be able to receive the signal on the output of the speakers. So this entire section here is my next task. So for now, I'm going to sign off. I hope this hasn't been too tiresome, but this is the sort of thing that I like to do slowly, because you never know what you're going to find. And yeah, I'm just looking at the schematic now, and it's starting to get colorful, which I like. But We've got a lot of work to do. Still a lot of work to do. So what I'm going to do now is thank you for your company. I hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon or on PayPal. Links are in the description below. Once again, thanks for watching. Bye for now and stay safe.